Okay, so in the previous video, we talked about some of the limitations of solving a system of linear equations graphically. What we're going to talk about right now is our first algebraic technique for solving systems of linear equations, and that's the substitution method. So here are some pointers that you can follow, or some tips that you can follow when you're solving a system of linear equations using the substitution method. So step one says solve one of the equations for one of its variables. When possible, solve for a variable that has a coefficient of 1 or -1. Step two, substitute the expression from step one into the other equation and solve for the other variable. And then step three, substitute the value for step two into the revised equation for step one and solve. So I know that that sounds a little daunting, but what we're going to do is go through and work through some examples so you guys can feel comfortable with this technique. All right, so example one reads solve using substitution, and we have these two equations right here. Now these should look familiar because these are the ones that we solve graphically, or excuse me, this is the system that we solve graphically in the opener. So what you should notice here is that both of these equations are solved for y in terms of x. So what we can do here is, since y, these things are equivalent to each other, I'm going to replace y in the first equation with -3x minus 5. So let's go ahead and do that. Let's replace this y with -3x minus 5. So -3x minus 5 is going to equal 2x plus 1. So what we have now is one equation and one variable, and we are very good at solving these now. So what I'm going to do is I'm going to solve for x. So let's add 3x to both sides. And that's going to give us -5 equals 5x plus 1. We'll subtract 1 from both sides of the equation and get 5x equals -6. And then divide both sides by 5. And we're going to get x equals -6 over 5. Now this is good news, because if we take an approximation, or if we represent this as a decimal, -6/5 is equal to -1.2, which is the x coordinate that we got graphically in the previous example. So now that we have the x coordinate of the point of intersection, or the x coordinate of the solution to this system, we need to take one of the two equations up here, okay, one of the two original equations, and then determine the corresponding y coordinate of the point of intersection. So let's go ahead and take this top equation and do that. So y equals 2. Now we know the value of x for this point of intersection is -6 over 5, so I'm going to replace x with -6 over 5 plus 1. And now when we evaluate the expression 2 times the quantity -6 over 5 plus 1, that should give us the y coordinate that corresponds to this x coordinate, or the y coordinate of the solution to this system. So let's go ahead and do that. 2 times -6/5 is -12/5 plus 1. 1 expressed as a fraction with the denominator of 5 is 5 over 5. So y should equal -12 over 5 plus 5 over 5, which is -7/5. And again, if we take a decimal representation of -7/5, we get -1.4, which is what we got graphically. Now when we're finished, what we want to make sure that we do is represent our final answer as an ordered pair, and check our solution, whether it be graphically using Desmos, or we can substitute this point back into both equations. And again, this point should make the left and the right hand side of both of these equations equal to each other. Okay, so that was one example. We're going to work our way through two more, and then you guys are going to practice them on your own. So let me erase the board here real quick and advance this slide. Okay, so we have two more equations, or two more systems of equations, that we're going to solve using the substitution technique, or the substitution method. Now, if we look here at example number 2, we see that the top equation is solved for y in terms of x. So what I'm going to do here is I'm going to replace y with 3x plus 2, because y is equal to 3x plus 2. and I'm going to rewrite that equation right here. So it's going to be x plus 2 times 3x plus 2 equals 11. X plus, we're going to distribute the 2, so 6x plus 4 equals 11. And now we're going to go ahead and solve this equation. So we're going to get x plus 6x, which is 7x, plus 4 equals 11. We're going to subtract 4 from both sides. We're going to get 7x equals 7. My handwriting is a little messy, I apologize. And then we'll divide both sides by 7 to get x equals 1. Now what we're going to do is we're going to use this top equation to find the corresponding y coordinate. So y is going to equal, we're replacing x with 1. So 3 times 1 plus 2. So y is going to equal, it looks like 5. So the solution to this system of equations is 1, 5. Now what we're going to do is we're actually going to check this one so you can see, so I can demonstrate for you how this works. So what we're going to do is we're going to replace y in this top equation with 5 and x with 1. So the original equation is y equals 3x plus 2. Y gets replaced with 5. X gets replaced with 1. And what we'll see is that 5 equals 5 is a true equation, which means that this ordered pair works in the top equation. Now let's see if it works in the bottom equation. So again, the original equation is x plus 2y equals 11. X gets replaced with 1. Y gets replaced with 5. So 1 plus 2 times 5 equals 11. 2 times 5 is 10, so 1 plus 10 equals 11. 11 equals 11 is true. And this should happen anytime you get a correct solution to a system of linear equations. That ordered pair should work in both equations. All right, now let's take a look at example number 3. In example number 3, what we notice is that both equations are written in standard form. So what we're going to have to do is solve one of the two equations for one of the variables in terms of the other. Now, when I look at the top equation, what I notice is that the coefficient of x is equal to 1. So I'm going to solve the top equation for x in terms of y. Now, what I mean by that is this: x minus 2y equals -6. I'm just going to isolate x. So in order to do that, we're going to add 2y to both sides, and we're going to get x equals 2y minus 6. So now we have an expression that's written in terms of y that's equivalent to x. So what we can do is we can replace x in the bottom equation with 2y minus 6 because they're equal to each other. So let's go ahead and do that. 4 times 2y minus 6 plus 6y equals 4. So now what I'm going to do is distribute the 4. We're going to get 8y minus 24 plus 6y equals 4. We're going to combine like terms. So the like terms in this case are 8y and 6y. So we get 14y minus 24 equals 4. We'll add 24 to both sides, get 14y equals 28. And then we're going to divide both sides of the equation by 14 to get y equals 2. So the y coordinate for the point of intersection of these two lines is going to equal 2, or the y coordinate for the solution to this system of equations is equal to 2. Now we need to determine the corresponding x coordinate. So we can use the bottom or the top equation. Again, I'm going to use the top equation because the coefficient of x is equal to 1. So x minus 2 times, we're going to replace y with the value that it's equal to, and that equals -6. So this is going to be x minus 4 equals -6. Add 4 to both sides and we get x equals -2. So the solution to this system is -2, +2. Now, if we go through and we check our answer, -2 minus 2 times 2 is -6, so -6 equals -6. That's 4 times -2 is -8. 6 times 2 is 12. -8 plus 12 equals 4. So that is indeed the solution to this system. Circle that. So I hope this video was helpful. You're going to try some practice on your own. We'll see you in the next one.